Good Lord, ride all the way.
A 10.
9,
8.
7,
6,
5,
4, 3, 2,
1. Hello and welcome to Slooh, especially Slooh members watching on the live channel. Now don't forget you can snap images using the star share camera below the show's video panel, and you can also use the chat box to the right if you want to ask us any questions. So what are we doing tonight? Well, hot off the heels of last night's full flower blue moon, still having some difficulty saying that, we have teamed up with our friends at Astronomy Magazine to bring you the opposition of Mars live. So a big welcome goes out to Astronomy Mag readers watching the show tonight too. I'm one of those, by the way. I subscribe to Astronomy Mag. You can ask us questions as well. You can send us your comments or even your own Mars images to @Slooh if you've got those. Now then, what have we got? We have got live views of the red planet tonight from our flagship observatory here at the Institute of Astrophysics of the Canary Islands. Now let's take a look at the various live feeds that we've got tonight. Now the first one is our all-sky camera. Now you can't really see it in this, but we've got we're in a kind of thick layer of haze. This is a special low light camera that operates at night. That's not the sun, that's the moon shining there. Now to kind of make sense of this image, tip your head on one side like that, and the things that you see down at the bottom, those are the Slooh telescopes that Slooh members use every night. So we use that particular camera to monitor conditions up here at 8,000 feet altitude on top of a volcano. Now we've also got our constellation cam running tonight, and here, now this one is mounted on an equatorial telescope mount, so this one is twisted as well, but on this one, if you turn your head the other way so that the moon's down at the bottom left, you can see Mars right at the top of that image. So that's showing the moon, Saturn, Mars and Antares at the heart of the Scorpion, and we'll point all of those out to you a little bit later on. We also have, by the way, members, you can snap that in the Starshare camera tonight, so you can make a nice little time lapse of that, of the moon gradually moving away from the planets and the stars there. We also have our live meteor cam. Now this is a live video view, and this is a super view that we've got here tonight. Now here, once again, this is slightly tilted, and you can see the horizon down at the bottom right-hand corner there, and we can see the moon really shining brightly there, but there just below the little Twitter birdie, that is Mars, and the rest of the constellation of Scorpius, which we're also going to be talking about a little bit later on. We want to hear from you guys, actually. Bob and I were talking before the show, and we were having this discussion. What's your favorite between Scorpius and Orion? What's your favorite constellation out of the two of those? So we want to hear your thoughts on that one. So in the chat box, please, or send, just tweet that to @Slooh. We want to hear what your thoughts are about that. Now then, we also have images from our 17-inch telescope here. We've got a 20-inch telescope and a 17-inch telescope here. But unfortunately, you know, even a couple of nights ago, Mars was still showing up okay in this, but it's got so much brighter just over the last couple of days that actually the images are getting really quite burnt out. So unfortunately, we're not going to see any detail there. The seeing conditions here in this haze don't really help very much either. But we do have a live video stream from our new solar system telescope. Now this is a highly magnified view, so it really couldn't be worse conditions for planetary observing tonight. With the seeing conditions, the atmosphere, you can see it shaking around all over the place. In fact, that little shake there must be some wind as well tonight. But we can pick out more features in this than we can the other views tonight. So Mars, the red planet. You would probably think that we'd know all there is to know about our planetary neighbor. But new discoveries are being made virtually every week from the various Mars missions currently underway. Now, is that dusty red planet dead? Did it ever harbor life? Was the Martian landscape sculpted by mega tsunamis generated from asteroid impacts, as suggested in a study that was released only last week by the Planetary Science Institute in Tucson? Are NASA and other space agencies, are they hiding evidence of life on Mars? The most recent accusation this week being that they're hiding the fact that there are trees growing on Mars. Maybe Matt Damon is tending those at the same time as his tomato plants. If I see an image of that, I'll believe it. But back to reality. How was Mars seen in ancient cultures, some of whom saw Mars as a really important figure in their belief systems? And of course, what does it mean when a planet is at opposition? Mars is at opposition tonight. We'll be answering these and many more questions about that rusty old planet in the next 30 minutes. And to help me do that, I would like to welcome Slooh astronomer and Astronomy Magazine columnist Bob Berman.
Well, great to be here. This is a historic event, and I hope a lot of our Astronomy Magazine subscribers and readers are with us. Of course, I've been with the magazine for more than a quarter century. Love the readers, and we've got a great relationship. So I've been with Slooh for over 10 years, since the beginning. So this marriage was really made in the heavens, I would say.
It was.
And this is a historic event that we're combining forces tonight to bring us the Martian opposition. I'm very happy to be here.
You brought us together, Bob. So last night you were wearing 2 hats. Tonight you're wearing 3. The very fetching one that you're actually wearing, and as Slooh astronomer, and as a columnist for Astronomy Magazine, which I subscribe to as well. Now, I read your Strange Universe column every month, but for viewers of the show who haven't picked up a copy of Astronomy, can you tell them a little bit more about what you write about in your column?
Well, the whole idea is to explore aspects of the universe that generally are overlooked. The odder, the weirder, you know, we really get far out with it, with humor, much of the time. And it's proven to be very popular over the years. So
well, it has. It has. And
yeah,
I know it's
we also try to go on that page in new directions so that it's not predictable. If whatever was there last month or the month before, it's going to be something very different this month. So,
well, it's always entertaining and informative, and like I think many readers, and I think I saw a poll about this somewhere. Just like me, it's the first page actually that I flick to every month. But anyway, to tonight's show, the opposition of Mars. Now, Mars and the Sun are on opposite sides of our sky. So when the Sun sets in the west, Mars rises in the east. And around local midnight, wherever you are, Mars reaches its highest elevation and dominates the skies, magnitude -2, which is actually giving us some of the problems tonight of imaging it. It's just too bright for our big telescopes. But Bob, Mars isn't at its closest to Earth for another 8 days. So why is that? A lot of people think that opposition is when the planet is actually closest to Earth.
Yes, and that's true of every other planet. If we're looking at Jupiter or Saturn, which is coming to opposition in only, I think, 11 days from now, usually the closest approach is within a day of the opposition. Mars has a greater difference than all the others. Part of it is its nearness to us, but the main thing is its eccentric orbit. It's so out of round that when we go to meet it, and you add the third dimension, we don't necessarily meet up at the same time that it's closest. So it's actually going to get a little bigger and a little brighter in the telescope. Since we have Astronomy Magazine readers with us, some of them may know that you measure eccentricity or roundness or its lack by a number between 0, which is perfectly round, and 1, which is a stretched out ellipse that reaches the extreme of ellipse. Look how round Earth's orbit is. The roundest of all the planets is Venus. You can't forget its eccentricity because it's 007. We talked about that a year or two ago, Paul. Remember? 0.007. Earth's eccentricity, 0.17. Again, very easy to remember, and we're 10 times more out of round than Venus is. But now we get to Mars, and it's got an eccentricity of 0.02. In other words, it's another 10 times out of round than we
Yeah.
are. So when we meet up with Mars, with that eccentricity, and you add that, it's a little tilt, about 1.85 degrees from the plane of the ecliptic. In the third dimension, its opposition date is rarely the night that it comes closest.
Right, and I think we've got some graphics actually that we can show a little bit later. I was also looking up some facts and figures on this a little bit earlier, and the two planets are currently getting closer and closer all week at a rate of around 300 kilometers per minute. That's 186 miles per minute. That means that by the end of this show, we're going to be 5,600 miles closer to Mars. Now, yeah,
that's great.
it's going to be 500,000 miles closer to Earth over in the next 8 days' time. I mean, that sounds like a huge amount, Bob. What's that going to do to it visually? Is it going to get bigger? Is it going to get much brighter?
A little brighter, and certainly it's 18 arc seconds. Now, old time observers would often say that you really need 20 arc seconds to see Mars decently, because anything smaller than that, and you have to use too much magnification, which also simultaneously blows up the turbulence. Look at it tonight. This is a night of unusual turbulence, and so that's not why we're not seeing the kind of details that, you know, if you're lucky or you're a place with very good seeing, you can get the dusky features. But as David Levy, you know, he and I had this discussion not too terribly long ago and agreed that Mars is the most challenging of the planets and the most likely to disappoint, because everybody has an image of how it should look. Thanks to the Hubble Space Telescope, thanks to the many Martian missions, we all are used to seeing stunning detail. And so actually using a good backyard telescope, or even the great Slooh telescopes tonight, unless you hit it on a night of extraordinarily good seeing, you're just not going to come close to matching the spacecraft or the Hubble images. And that's just the way it is. Whereas in contrast, and I'm saying this a little defensively because this being our first show with Astronomy Magazine, viewers, I urge you to tune in on a night that we're, let's say, looking at galaxies. And there we see such detail in the Whirlpool galaxy. We see the blue color of the spiral arms, all natural. We never do false color. The campfire orange of the core of the galaxy, the details of the spiral arms, and things that you'll never see through a backyard telescope, and you'll be hard pressed to even achieve with good astrophotography. And Slooh does that routinely. So tonight, what we're getting on Mars, don't judge what Slooh produces by this bad seeing night as we're looking at Mars. So with that defensiveness being said, what? I'm sorry,
I got up this morning, Bob, and you know, I just looked out and I could hardly see the volcano Teide, you know, and it was just sitting in this thick, you know, it was like sitting in marshmallow. And in fact, it was improving a little bit earlier, but just now, as you were saying all of that was the worst little period that we've had all evening. But you know, we are at 8,000 feet. That's why the telescope's up here. Usually we're in this beautiful, stable air mass. But anyway, let's carry on going. There's actually some images from 2007 apparition. And that was taken with a normal CCD camera, those images. But you can see there how much, you know, Mars grows over the course of an apparition. But let's go back to opposition. How often does an opposition of Mars occur? And is it the same for every planet, Bob, or is it different?
Oh, no. The Martian oppositions are 26 months apart. And an opposition can just be pictured as Earth is going around the sun. And let's just consider planets outside of our orbit. In other words, the superior planets, the planets that all travel more slowly than we do and have longer paths around the sun. So that means Earth calls the shots. We go around the sun once. The planet, meanwhile, has moved on somewhat. And then we have to travel somewhat more to reach that lineup where we're in between the planet and the sun. That's what an opposition is. When it comes to planets past Mars, that's very easy to figure, because Jupiter goes around the sun in 11.86 years, call it 12 years. So as we go around once, we just have to go one more month and we're back to the next lineup with Jupiter, the next opposition. So oppositions of Jupiter are just a month later each year. Saturn, with a 29.4577-year orbit around the sun, let's round it off to 30, means that as we go around the sun, we just have to go 2 more weeks. 1 year, in other words, plus 2 more weeks, and there's the next opposition of Saturn. Very easy to keep track of.
Right.
But Mars is so close to us and has a speed similar enough to ours that we really have to play catch up. We go around the sun once after an opposition, and Mars now has moved halfway around. We go that other half, Mars has moved another quarter of the way around. We cover that quarter, and to make a long story short, it's more than 2 whole years. And it's the only planet that does this, 2 whole years around, plus another 2 months for the next opposition. And look at this graphic that we have for you, showing that the oppositions are not equal. We can meet Mars at a narrow point in our orbit, as we did on August 28th, 2003, where we came closer than we have in 5,000 years. Or, even though we've waited 26 months for the opposition, we could meet at the wide part of our orbit, shown here in the right side of the image. This opposition is a little bit farther away than average. It's not as bad as the last oppositions have been for the last decade. They've been really crummy. And Mars has only been 15 arc seconds wide, 14 arc seconds wide.
Yeah, this shows the difference. It makes
now
a
it's at
huge
least grown
difference.
to 18, so we can live with that.
Yeah, I mean, and this one, these distances, it says it all here. But 2018 is certainly a lot better than this year, because I think then we're going to be 35.8 million miles away. But, you know,
that's going to be a good opposition, yes. We'll be able to see a lot more detail then.
Yeah. I always feel, Bob, that this makes more of a difference with Mars than any of the other planets. I mean, you can virtually write off certain years. And of course, then we have the other issue that sometimes we have a nice close approach between the 2 planets, but we get a dust storm, and a dust storm totally obscures the entire planet. Didn't that happen was that 2006?
Yes. And it does obscure the planet. And then there's yet another factor, and that is how high up is Mars. Now, of course, now it's in our beloved constellation Scorpius. We all love Scorpius, but it's a low constellation. So it means that Mars is seen through thicker air. Now, that doesn't help. And so the Martian oppositions, where they're in Taurus and Gemini and Cancer, you're looking through much less air, and that gives you a break too. So the oppositions really vary quite a bit. So this one, if you take all the factors into consideration, how far it is, what kind of declination it has, this is actually a little bit less than, let's say, an average decent opposition, but it's still better than any we've had in 10 years. So you can see the glass half full or half empty.
And of course, it may be low in the sky. Scorpius might be low in the sky for Northern Hemisphere observatories, but from the Chile observatory, you know, it's lovely and high, and that's also been great for Saturn as well this year. We've got some bad weather down there at the moment, but you know, those telescopes are nicely tuned up for the planets as well. Now, Bob, you are going to be back a little bit later when we'll talk about that strange and mysterious planet that seems to have captured our imaginations more than any other planet, really. And we'll discuss whether either of us would be interested in visiting the planet if Elon Musk is feeling a bit generous and offers us a free ride on his little retirement journey that I think he's planning. So we'll see you a bit later, Bob. So have a think about that one.
Okay.
Now, don't forget, viewers, you can ask questions by using the chat box on the live channel at slooh.com or by tweeting to @Slooh. We are going to take a very short commercial break now, but coming up next, we've got Slooh's mythology expert, Trisha Ennis, who's going to tell us about the importance of Mars in ancient cultures. But first, to those Astronomy Magazine readers out there, if you're enjoying what you're seeing here at Slooh, and I certainly encourage you to watch more of our public shows as well, I want to encourage you to become a member of the Slooh community. It's free to try, and there's absolutely no obligation. You know, at its core, members control the robotic telescopes both here in the Canary Islands and at our Chile Observatory via this simple but powerful interface to see all that glows in space. In fact, Slooh members have taken well over 4 million photos of over 50,000 different objects in the sky over the last 12 years. And it works just like a jukebox. One member is in control of a telescope, while all the other members get to see what the telescopes are doing live. As Bob said earlier, it's full color live. And then everybody can contribute to the ongoing conversation over in the Slooh clubhouse, which is where everybody hangs out. And we always say it's a bit like cavemen and women gathered around the campfire. We wonder together about the universe and share the great diversity of all of our perspectives. It really is space for everyone here. So please do give it a try, astronomy readers, and in the process, you'll be supporting our ability to make our other programs available to the public. Now, don't go anywhere. We are going to be right back after this short commercial break with Trisha and the mythology of Mars.
Hello, and welcome back to Slooh's broadcast of Mars at Opposition. My name is Trisha Ennis. I am the resident mythology expert and cultural correspondent here at Slooh. Now, over the last few months, we've been talking a lot about the ways that the ancient cultures of Greece and Rome helped to name pretty much everything we see in the night sky, from the constellations to the planets. Now, despite the fact that those names actually come from the Roman tradition, most of that discussion has focused on the mythology of Greece. That's because they came first. The Greeks were largely responsible for putting together all of those myths, while the Romans simply adapted them, renaming a lot of the gods and the heroes to fit their own beliefs after they conquered Greece. They would actually do the same with religions of places like Egypt as well. Tonight, though, I actually want to focus on the Roman view of Mars, because unlike the majority of the myths we've discussed in the past, the way the Greeks and Romans viewed Mars highlights the differences between their two cultures. Bet you didn't know that a planet so far away could offer insight into cultures right here on Earth. The god of war, who was referred to as Ares in Greece, Mars in Rome, had vastly different personalities depending on the culture doing the telling of those stories. In Greece, a culture predicated on knowledge and scholarship more than conquest, Ares was a symbol of upheaval and unrest. He was seen as a necessary evil, much like the wars he presided over. But he wasn't always very good at winning either. He was seen as the brute force approach, and in many cases was put into direct contrast and conflict with his sister Athena, who was the goddess of wisdom and military strategy. Nowhere was this more prevalent than in Homer's The Iliad, the epic poem which tells the story of the Trojan War. In it, Ares is on the side of the Trojans, arguably the bad guys in the story, while Athena is on the side of the good guy Greeks, who are the ultimate winners of the war, and they win the war based on cunning with the Trojan horse. Now, their father, Zeus, even goes so far during the poem to tell Ares that he is the least favorite of all of the Olympian gods, which really isn't something you want to hear from your father. The only place in Greece where Ares was really worshipped with temples and sacrifices was in Sparta, the Grecian city well known for its heavily militarized society, in direct contrast with Athens, named for Athena, which was all about learning and scholarship and wisdom. It's not surprising, then, that the society of Rome, itself highly militarized, would seek to alter the status of Ares when they conquered Greece. In Rome, Mars, with his new name, was second in importance only to Jupiter, the Roman version of Zeus, who, no matter the mythology, was always the king of the gods. Rome had a much different relationship with war than Greece. Where the Greeks saw war as disruptive and destructive, the Romans saw it as a means of maintaining peace. It's counterintuitive, but it made sense for them. If you're so successful in war that your enemies are too afraid to rise up against you, then you've won yourself a pretty secure peace. Anyway, Mars represented the perfect soldier. He was a guardian of the Roman people, specifically of the Roman legion, and their crops in the seasons when growing food was more important than waging war. He was even credited as being the father of the Roman people, so to say, in their mythic genealogy. In some traditions, he was said to have fathered Romulus and Remus, the agreed-upon founders of the city of Rome. Mars' importance in Roman tradition even made its way into their calendar. In the original Roman calendar, which is credited to Romulus, there were 10 months. Many of the later months simply count the number of months, December being the 10th. But the first month of the year was Martius, which we refer to now as March. It's the month named for the god of war, Mars. The birthday of the god was said to be the first day of his month, and thus, because it was the first month of the year, it was the first day of the new year, which is pretty important. And jumping back to the planet and the curious way it got its name, you might think, after all of this, that the Romans named the planet Mars because it was one of the brightest planets in the sky, and therefore very important. But the truth is actually much more interesting, at least if you ask me. The planet Mars, throughout human history, has always been associated with war and death, and with various deities associated with those things. From the earliest civilizations of Sumeria and Babylon, to the early people of India, to the Greeks, and finally the Romans, each of these cultures has associated the red planet, which they saw as a star, with the same characteristics. Now, likely this is because of its red color, and perhaps because it's far less constant than the stars around it, because it's a planet, it's constantly moving. Whatever the reason, I think it's safe to say that it really is fascinating that it wasn't just one culture that looked up on this shining red dot in the sky and thought this way, but that cultures much older and in different places in the world did the exact same thing. Paul, back to you.
Wow, I've just been taking a closer look at the live solar system telescope view, and it was giving us some little tantalizing glimpses into those perfect moments of seeing when the detail starts jumping out at you. But no, conditions are against us tonight, but we can't fight conditions. That was Trisha Ennis, Slooh's resident mythology and cultural expert. Trisha and the production team were in New York yesterday filming a UFO convention. I can't wait to see what they were up to. I have already seen Trisha's tinfoil hat, and it has to be seen to be believed. But anyway, here we are enjoying the opposition of Mars. The best place to watch it is at slooh.com, where members can use a StarShare camera to snap their own images of the feeds tonight. And you can also ask questions using the chat box. You can also send us your own images, poetry, or whatever Mars-related stuff you want to by tweeting to @Slooh. Now, let's welcome back Slooh astronomer and Astronomy Magazine columnist, everybody's favorite, Bob Berman. Welcome back, Bob.
Thanks. It's great to be here. You know, while Trisha, I loved what Trisha was telling. I learned some new stuff. When she was talking about the red planet, we always refer to this as the red planet. But honestly speaking, if you were to try to assess the color by using, let's say, a swatch from a paint store and compared it, honestly, it's more like pumpkin, isn't it? It's on the orange side of yellow. It's not even fully orange when you think about what a pumpkin really looks like. It's not even quite orange. It's yellow orange, and it's certainly not red any more than anybody would call a pumpkin red. So just so if you're a real beginner in astronomy, just know that the red planet, just like when we talk about giant stars as being red supergiants, those are labels, those are terms. They're not meant to be actual descriptions. They're neither Betelgeuse nor Antares, just below Mars these days, are actually red. They're actually very close to the color of Mars, which is yellow-orange. Just thought I'd mention that.
And we were talking about colors of moons last night, blue moons and blood moons and things like that. But you've heard it here officially. The red planet is no longer the red planet. It is the pumpkin orange planet. So Renamed by Bob. Hey, listen, Bob, you're among fans here at Astronomy Magazine and at Slooh, so you know that we'll bow to whatever you say. Now, if viewers want to see this kind of awesome spectacle, if we can go over to the meteor cam, actually, if viewers want to see this awesome spectacle from their own backyard or garden tonight, where should they look to see Mars, and what else is visible in the vicinity, Bob?
Oh, yes. Well, just go out the first few hours after nightfall. No, no, never mind that. 10 o'clock, 11 o'clock, local midnight is good too. Lowish, not terribly low, but lowish in the southeast, eventually becoming the south, midnight, 1 o'clock. And there's the moon. The bright star to the right of the moon is Saturn tonight. And the orange-looking things that are not Saturn are Antares low and Mars highest up. So they're
Actually, I
all
think they're
really
just off
quite
this. They're just off this shot now, Bob, aren't they? They're off the
yes.
top. So maybe we can flick to the constellation cam. Actually, this was a view. This was a
Yeah,
view that
this is
I
good.
snapped this evening. So
Yeah,
this
this is
is
very
what people
nice.
are going to see as it rises. So take us through that then, Bob.
Okay, the stars below Mars, we have A Crab on the left. That's actually Beta Scorpii if you're using the Bayer designation. Beta, Delta, and Pi Scorpii are the three stars that form the claws of the scorpion. Those three prominent blue spectral class B stars that are to the right of the famous Antares, to the right of it as most of us face it. Now, Beta is listed as A Crab, and although that is, one of its names, you also might know it as Grapheus. That's how I learned it when I was a kid. So it has a few names. They're all of Arabic origin. Chuba, there is the middle star. That's Delta Scorpii, you could call it Shuba. The Bayer designations perhaps are better known, the Beta, Delta, Pi. But here's the thing. All three of those stars below Mars form a beautiful color contrast. They're all blue. They're all spectral class B, meaning very hot, very young stars. They're all about the same distance. They're all about 500 light years away. So they're buddies. They're hanging out together. They were probably born at around the same time. And listen to this. All three of them are binary stars. In the case of Shuba, as we listed there, or Delta Scorpii, many stars that are all going around each other with various kinds of orbits of different time periods. But all three of those stars are multiple stars that are where all the components are B, spectral class B. B is one of the rarest of the spectral types in the galaxy, and yet in the entire beautiful constellation of Scorpius, just about all the stars are spectral class B. They're blue stars except for Antares. So we were talking about that earlier, Paul and I, that if you had to vote, would you pick Orion as number one, or you pick the Scorpion as the best constellation? And Paul was saying, and he's probably right, that from his native England, since the tail never rises, and even from northern United States and all of Canada, the tail either scrapes along the southern horizon like a vacuum cleaner, or at most it just clears it by a few degrees, so you don't see it well. But from the Canary Islands, go to Mexico, go on vacation to the Caribbean, where it rises up higher, and you couldn't argue with anybody who said, that's, let me put that number one of the 88 constellations, perhaps especially so since it forms a pair along with the teapot of Sagittarius, and doubly especially so because when you look to the left side of the Scorpion, you're looking toward the heart of the Milky Way galaxy, and the brightest part of the Milky Way is there too. Whereas in Orion, you're seeing just about the faintest part of the Milky Way because you're looking away from the center of the galaxy. You're looking in the opposite direction.
It's strange you mentioned the asterism of the teapot in Sagittarius as well, because that actually is my favorite asterism. But of course, I don't see that from England at all. But when I'm here in the Canary Islands, Scorpius later on tonight, and there we see actually the sweeping tail, the stars at the bottom of the image there is the sweeping tail of Scorpius. And that's what it does. It kind of writes itself across the sky. It's just beautiful curves. You don't really have to use very much imagination to picture this huge scorpion. But at this time of year, Scorpius, when it sets right behind Pico Delta, with the volcano here, which is 12,000 feet high. We're at 8,000 feet here. And it seems to kind of lay down gracefully as it sets below Tadia. It's just such a gorgeous sight. In fact, Slooh members, have a look in the clubhouse, because I did a few time lapses of this a few years ago, and also marked up the constellation so you could see it quite clearly. But we still want to hear in chat or on Twitter, what would be your favorite constellation if you had to pick out of Orion and Scorpius? So we want to hear what you think. Now, Bob, fountain of all astronomical knowledge, as Slooh members and Astronomy Magazine readers know, have you got any particularly fun facts about Mars before we go a little deeper into the red planet?
Well, you'd think I would have prepped for that, so let me just free associate. I like the fact that the Martian day is only a little bit longer than ours. You know, we spin around once in 23 hours, 56 minutes, and 4 seconds. Mars goes around in 24 hours, 37 minutes, and 23 seconds. So it's only about half an hour longer of a day than ours. That's interesting. Its axial tilt is only a degree more than ours. It's most similar of all the planets. And
but doesn't that vary,
of course, it's final at 4,000 mile diameter, half the size of Earth, and 1/3 the gravity, 11%. I happen to remember that 11% of our mass. So it's a low mass body, and that's why with that weakish gravity, it doesn't easily hold on to an atmosphere. So unlike in the movie The Martian, the air on Mars is only 1% as thick as ours, and therefore a windstorm of 100 miles an hour on Mars only produces the same effect that we'd get on about an 8 or 9 mile an hour gentle breeze. And that's why that movie, although I enjoyed it, it showed poor Matt Damon being punctured, stabbed by some material that was being blown by these violent winds, and that would not happen on Mars, because even the most violent winds, because the air is so thin, would not barely ruffle any papers.
Hollywood producers, you'll never get anything past Bob Berman, so you'll have to try harder, Matt Damon, next time, please.
No, I bet everybody in astronomy, I bet all the readers of Astronomy Magazine noticed that and were shouting at the screen. But then, you know, they did other things so well in that film that you have to allow them some license. Someday I'd love to have a vote on the all those space movies recently and see what our viewers here at Slooh and what the Astronomy Magazine readers, if you had to choose between, let's say, Gravity, The Martian, Interstellar, you know, we've had some big budget films.
Or are you Armageddon? That's where the big arguments normally come, Deep Impact or Armageddon. So maybe we should do a show, Bob, on just that. Now, we have got actually I'm already being told actually Deep Impact is best, which I have to agree as well. But we've got Trish Ennis. She's saying that Orion is her favorite only because it's the first one that she learned outside of the Big Dipper. Big Dipper is actually Ursa Major. Slooh member Jamie says Orion as well. And yeah, loads more about Orion. Stephen says his is the Winter Circle, Taurus. So, you know, some of those rather large asterisms. So, Bob, it sounds like you and I are kind of in the minority thinking Scorpius at the moment. But let's get back to Mars as we see this. That you can see here, the seeing has improved a little bit, but is still not giving us the crisp images that we would love. I mean, it's getting really high in the sky now. But
all right, then let's add a little bit about its moons. You know, it's got these 2 little moons, one of which, Phobos, goes around in only 8 hours. You know, our moon essentially takes a month, 27.32166 days, 27 and 30 days. I have to learn to round off because I can't help it. It's crazy. It's like I should see a therapist about that. Its moon, I'm rounding off, 8 hours, and then the second moon, Deimos, a little bit over 30 hours. But these are very fast satellites. And by the way, probably the worst names in the universe to have your moons named Fear and Death. Phobos, of course, means fear. You know, we have a phobia about something. Fear and death. That's not a good sign. And almost to live up to those names, Phobos is the moon in the solar system that's spiraling inward at the fastest rate, and it's going to just crash onto the Martian surface before very long. You read different figures, so I'm not sure which is correct, but a matter of some, perhaps even less than 1,000,000 years. And maybe one of our viewers can say, no, I've recently read a more up-to-date figure that it will disappear and collide with Mars in only X number of years. I'd like to hear what the latest is. But in any case, it doesn't have long to live, so it's going to live up to its name, fear. I mean, if we have colonists on Mars in the future, they'll have something to fear as this moon comes crashing in.
Now we must have a conversation after the show, and in fact, maybe viewers can comment on this as well, because I was given a little tidbit by Trisha before the show started, and I had always thought that those moons were named in the way that you've just suggested, Bob, but Trisha was suggesting that she's found some writing that says it's actually terror and panic. So that'll be an interesting one that we must follow up on to see where those different meanings derive from. But certainly Phobos, as in phobia, as fear, it makes a lot of sense, doesn't it? But going back, and this is part of it. As human beings, we seem to have this kind of preoccupation with Mars, more so than any other planet. We imagine the possibility of Martians. It seems like the next place in our solar system everybody wants to go. What do you think it is about the red planet that captures our imaginations in the way that it does?
Well, other than the fact that fear is juicy and it's the red planet and has so many centuries and more of association with blood and war and fire and all the rest, just overlooking that, it's a default thing, Paul. There's no other choice, because Mercury obviously is out of the question. Venus is out of the question because its surface broils at 850 degrees day and night. It's absolutely deadly, and its surface pressure is 90 times that of Earth. So that's about 50 times more than a pressure cooker. These are very instantly lethal conditions on them. And then beyond Mars, you don't have any place to land. You have gaseous planets that your spacecraft would just be sucked in. There is some ammonia there, so your spacecraft would be nice and shiny and clean from the ammonia, but that would be the only positive entry you could do in the ship's log. If you wanted to land on one of the giant Jovian satellites, well, they're all orbiting within the radiation belt, the magnetosphere of Jupiter. That's deadly too, unless you landed on Callisto. The point is, there's no other place to go, really. If you want to go to a planet, only Mars offers remotely comfortable conditions. And of course, that's not comfortable either. The radiation, some estimates say that the radiation would destroy between 13 and 40% of a human brain in a 2-year mission. And even for us smart people, that's not good for you.
So radiation tablets. We'll take some of Elon Musk's radiation tablets.
It's not at all a comfortable place, but it's far better than any other world. So that's where we're going to go.
So what are your thoughts on whether or not Mars ever harbored life? We seem to be in eternal hope almost. Scientists seem to be in eternal hope that they're going to discover some kind of fossilized evidence of life. Well, what are your thoughts on that?
Well, maybe, there was water there. There still is ice there. There may be subsurface water to this day. And so far as we know, life always requires water. So it's still possible that there's some subterranean, I wonder what the word would be for Mars. Terra, of course, refers to Earth. I bet Trisha would know the answer to this. On Mars, you wouldn't say subterranean, you'd say what would be the right term? Somebody knows this.
Come on, viewers. We want your ideas on the option for that one. Trisha's saying sub-Martian.
Under the surface, perhaps it might still it's still possible if panspermia is correct. In other words, that life roams the universe, perhaps in the form of spores, or at least pre-life. We know all the amino acids are in space in great abundance
We're
in the
finding the
nebulae.
building blocks everywhere.
They travel in meteorites, in cracks, perhaps even in an interstellar fashion, and perhaps seed themselves whenever they collide with a planet that has hospitable conditions. So if you believe in that, panspermia, that life gets seeded whenever conditions are right, then life would be common. The few astronomers who don't believe in that essentially are saying that life on Earth is so rare that Earth is the site of a miracle, that this is, that it almost doesn't happen anywhere. But very few astronomers believe that now.
Yeah, you know, and as we find more and more solar systems out there, and we were talking to Lisa Kaltenegger during the Transit of Mercury show, and you know, some of the exoplanet discoveries now, you know, we're getting down to those kind of Earth sizes, we're getting down to that Goldilocks zone, discovering these planets. We've got another special exoplanet show coming up, actually, so keep your eyes open for that. We're going to be using one of the giant EAC telescopes, the Institute of Astrophysics telescopes here, to actually witness a live transit. We don't actually see the planet, but we'll see the star's brightness dip as the planet transits in front of that. So we're going to cover this more, actually, Bob, on next week's show. But I wanted to point out to viewers tonight that there was a study released last week which was suggesting that the Martian landscape has been sculpted by these huge tsunamis. They posited that huge tsunamis were caused by a large asteroid impact, and they released that study last week. And I mean, scientists have hypothesized for a very long time now, haven't they, that there was this huge ocean in the northern hemisphere of Mars. We can see this image of it here, and it's the Planetary Science Institute in Tucson, and that they're saying that they've found evidence that 3.4 billion years ago, I mean that's a long time, an asteroid crashed into the ocean, triggering this mega tsunami that plowed into the coast with waves as high as 400 feet. And the meteor left the asteroid left a crater of 90 miles across. And then they're positing that the problem was, when they came up with that, Bob, they couldn't find the beach. There was no evidence of the beach. So they've then come up, and this is what's being argued at the moment from various planetary scientists. They've then posited that there was a second meteor that came down during an ice age, which basically pushed all of the ice out and then covered over those beaches. They covered over all of that evidence that their first theory of the first asteroid impact. So we're going to cover that more, and we want to hear viewers' opinions on that. So hop off, and viewers, after the show, have a look and read up about that story. Now, Bob, we've got to cover this one only because, well, just because we have to. We're contractually obliged. There was a story that came out last week that NASA were hiding the fact that trees are growing on Mars. As I said on last night's show, I wondered why anyone would want to keep such an amazing discovery secret. But for those viewers who may have read that story, what would you say to them? Is it possible there are trees growing on Mars today? And please try and answer as seriously as you can.
Well, no, because we don't have the organic matter that trees would need. We don't have an atmosphere. There's too much radiation, and there's a lot of reasons that that couldn't happen. But the main thing is, whenever you hear somebody say that NASA is keeping it a secret, those of us who have been involved with astronomy for years, or involved with the media with astronomy, as you know, I was with Discover Magazine for 17 years before Astronomy Magazine, and I can tell you this: nobody keeps anything secret. Yeah. And the government never gets involved in trying to make astronomers not tell the world about discoveries. There's no mechanism in place, nor would we ever listen to it. If some government agency came into our offices and said, "Don't say this because it'll make people panic," we would just laugh at them and say, "Get out of here." Any astrophysicist who made a discovery, and the more amazing the discovery, the faster he would tell his girlfriend or boyfriend or blab it to all of his colleagues, and the word would spread through the internet within 24 hours.
Yeah.
There'd be no way to keep it secret. So the very idea of the government keeping anything astronomical secret, we all know, we who are involved in this, that it's just plain silly. They wouldn't do that, even if they wanted to. And why would they want to? If there were trees on Mars, or
well,
let's use an
we've got
extreme
an answer, Bob.
example, an object coming close to Earth that might collide with Earth. You know, let's say we all know we only have 2 weeks to live. You know, why keep it secret? Why?
But we've got an answer. We've got one possibility actually in the chat room, which is saying that the US government is keeping the trees secret because they want to harvest the lumber for themselves. So it's just a land grab. It's just another land grab. Now, anyway, let's move on from that one. Even if there isn't any life on Mars in the current epoch, there soon could be. A couple of private companies are now offering people the chance to be the first to set foot on Mars in a one-way mission. Now, hundreds of thousands of people signed up for that opportunity. I even heard of one organization who will go unnamed in this broadcast that offered to buy me a one-way ticket after our transit of Mercury revelation. So, Bob, what would you go to Mars if you had the opportunity on a one-way ticket? We've got people in chat saying they wouldn't go on a one-way.
No. Why would I do that? I mean, I could see if a person had serious credit card debt, or had some great problem, or really bad in-laws, or some reason that they wanted to permanently escape from Earth. But you have to remember that Mars is far more hostile than the most hostile places on Earth. Nobody's lining up to live on top of the Himalayas or 5,000 feet under the ocean. They're vast areas of Earth that could be colonized, and that nobody's there because life would just be too tough. Nobody wants to be there in these vast areas. Mars is 1,000 times more hostile than the worst places of Earth, because on Earth, at least you can breathe the air. On Mars, your life is based around technology. And if the technology fails, you're dead. There's also high radiation. I mean, maybe you'd like to get a CAT scan every half an hour or so, and you think that's a great idea to pass the time. Maybe you'd like to be in a place where you can't breathe, but the actual reality of being there, I think, would be far less attractive than the thought. And I understand what the thought is. It's the same reason people go to Alaska. It's you want to get to a place, in this example, a place without any zip code, no area code, no credit cards accepted, no pizza. You know, I mean, nothing. So I understand the allure of being in a place and you're the only one there, but my goodness, life would be awfully tough.
Exploration, I know it would be very tough, but the sense of exploration, there's so very little to explore and discover here on Earth. I've said actually for a very long time that I would take a one-way ticket to Mars. So, you know, I can hear people now dipping into their wallets to contribute to send Cox to Mars. But, you know, it's that sense of adventure and exploration and being the first. You know, we've lost that. I grew up, and you did, Bob, you know, with stories from, you know, the 17th, 18th, 19th century explorers, people doing the first thing, and they knew that their lives, and many of them died, they knew that their lives were in danger. But there's that innate thing, isn't there, in human beings that makes us want to explore and go places.
I think it's wonderful, and there will be people who do it. And my hat literally is often, if not literally, it's figuratively, my hat's off to them. But let's remember that woman physician in Antarctica 2 years ago who developed breast cancer, and being a physician, she knew what she had. The lump was getting bigger and bigger. She could not leave because it was the Antarctic winter. There was no way to fly her out. Finally, some very brave people flew her out earlier. I think it was a month and a half earlier than anyone had ever been evacuated from there. But she was in a position where she was helpless. And I wonder what the rest of us would think when the first Martian colonist who's in that position of not being able to have advanced medical care dies because of that, or not being able to have the modern pharmaceuticals that the rest of us can get so easily now. And nobody can come for at least 2 years on Mars because the Hohmann transfer orbit that allows Martian Earth connections only happen every 26 months. How fickle will the world be when we witness the first colonist expiring because of the conditions there? I wonder if that's going to sour people, and then everyone's going to go, "Oh, I get it now."
Yes, I think we're not. Yeah, we're not used to that risk. We're a very risk-averse society, and actually, the chat room shows that, Bob. Most of the chat room are agreeing with you. There's no way that they would take a one-way ticket, and some of them not even a two-way ticket, to the red planet Mars. As we sit here, the seeing is improving, and we're getting these little glimpses, aren't we, Bob, of some of those features, some of those Martian features. So it'll be hopefully next week. We've got the show when it's closest to Earth, so hopefully we're going to have some really good seeing conditions there. But we're going to wrap it up for tonight, Bob. Now, you are coming back next week when the planet
it'll
brightest
be
and
marvelous.
closest. So that's the closest in 10 years, isn't it, Bob?
Yes, exactly. We've had a series of nothing but very distant oppositions. So you can see even from the shape here, this isn't too bad. 18 arc seconds. We can definitely live with that. We do want to see more surface features. Let's see what happens. And the northern ice cap, this July it will be we're heading toward the autumn equinox for the northern hemisphere on Mars. So we should have a northern polar cap that shows up. In our Slooh view, north is up. So we're going to look for a little bit of a polar cap too, and see if we can't see that on our next show.
We were seeing it in some of the images from the 17-inch telescope last week. It was becoming quite well defined. But anyway, Bob, thank you so much for joining us tonight, and we will see you next week.
Thank you, Paul. My pleasure.
That was Slooh astronomer and columnist of Astronomy Magazine, Bob Berman. We've gone so over time. Apologies for that, but we've been enjoying ourselves. Now, if you haven't already picked up a copy of Astronomy Magazine, then you need to. Bob's Strange Universe column is an immensely entertaining and informative read. And don't forget, Slooh members, Bob also broadcasts live shows on Slooh on Tuesdays and Thursdays for Slooh members. Well, that does just about wrap up our coverage of the opposition of Mars tonight. We've had some fascinating insights from Slooh astronomer and Astronomy Magazine columnist Bob Berman. We've heard some of the Mars myth and lore from Tricia Ennis, our mythology expert, always fascinating to listen to. Thank you to all of those who have been chatting to us during the show. By the way, if you haven't been in the Slooh Clubhouse recently, check out the amazing NASA Mars image that Craig Edwards posted to the Clubhouse a couple of days ago. That looks glorious. Now then, before we leave you, I want to remind you of a couple of shows we have coming up on Monday, May the 30th. Mars, as we say, is at its brightest and closest to Earth in over a decade. We'll have live images of the planet, and we'll be joined by Martian guests, including the folks from the Mars Society. So they're going to add to that conversation that we just finished the show up with about living on Mars. They actually replicate some of those kind of conditions. And on Friday, June the 3rd, we will be heading further out into our solar system as we look at the glorious ringed planet Saturn as it too reaches opposition. That's always a good one, always looks fabulous through the telescope, so that's going to be a really great show. Well, that's about it for now. I'm Paul Cox. This has been a Slooh astronomical production, and we will see you all very soon. Good night for now.